Hey guys, welcome to another PowerPoint here. So today we're going to be looking at expanding quadratics and cubics. All this is, guys, is a minor extension onto the stuff that we've been looking at over the last lesson, where we used our FOIL method. So we're going to be referring to our FOIL method again today. And for reminders as well, in case you're that way. Okay, so we are looking at today how to expand our quadratic and our cubic polynomials. Okay, so first things first, we should probably have a really quick look. Okay, what is a quadratic? And of course, what is a cubic here? So activating some prior knowledge. Now, these are hopefully words that we've heard before, and the quadratic and the cubic simply refer to the highest power in a term. Okay, so let me give you an example. So we have the algebraic expression. Maybe it's x squared plus 2x plus 1. Okay, now this is a term that we call a quadratic. Now the reason for that is because it has this 2 up the top here. Okay, so that 2 is the highest power available in this particular expression. So according to our highest power, that is our defining characteristic for that term. So if we come down here and have a look at what a cubic is, maybe you guys might like to extend that idea. Think about, well, where have we seen cubed before? Where have we seen, cubes before? We see cubes in 3 dimensions. We see cubic numbers as our third power. So even if we then had, like an x squared term plus an x plus a 1, the 3 is our highest power, and our highest power is kind of like the descriptor of our term. So because our highest power is a 3, this term is considered a cubic, even though it also has a quadratic term in it, and a linear term in it, and a constant in it. Okay, so the takeaway is highest term slash power defines the term. Okay, that's how we're going to be thinking about it. multiplying every term in the second bracket by every term in the first. So we were calling this the FOIL method in the previous lesson. And we're just going to have a really quick warm up of doing the same thing right here, right now. Let's have a look at this problem. We have x plus 5 times x plus 2. And what we need to do is we need to FOIL this problem out. First terms multiplied together. So we have x times x, okay? And then we're going to do the outer terms. So x times 2 to get 2x. The inner terms, so we're going to have x and 5, or 5 and x, I suppose, makes sense that way around. And then the two last terms, so 5 and 2. Fantastic. We also need to, as the question says, simplify. And it's good practice to simplify always for these sorts of problems. Now, simplifying in this type of problem basically just means we're going to group our like terms. So when we have a look at this problem, we can see, well, there's no other x squared. There's no other quadratic terms, okay? So we don't have to worry about them, but there are two x terms, okay? So what we can do is we can group them together, simplify them. We end up with x squared plus 7x plus 10. Now, there is a nice little pattern that maybe some of you guys have started to identify. We have that 7 is equal to the sum of these two non-x numbers, okay? 5 plus 2 adds up to 7, okay? 10 is equal to the product of our non-x numbers. And that is something that occurs for all of these quadratic binomial problems. Okay, so let me just repeat. The number in front of the x is the sum of our two non-x values, okay? And then we have the final number, the non-x term, is always the product for our quadratic binomials. And this is going to be a really helpful tip when we come to factorizing these later on, okay? So what we're going to do is we're just going to make sure our familiarity with these problems is still there. So we're going to do that with a couple of weeders. So I'm going to leave you guys with this problem here. If you can pause the video, come back in a minute or two, and I'll see you then. Right, let's have a look. So hopefully we do our first numbers first, and then our outer numbers, our inners, and our last FOIL, okay? Matter of tidying these up a little bit, and we can simplify those there, okay? And this is the pattern that we can maybe start to identify here, okay? So the two numbers that have, the two terms that have x's in them, let's have a look. These ones here, so the 2 and the minus 5 after our FOIL, okay? Well, it was actually the sum of the two non-x terms, so negative 5 and 2. So we can start to kind of shortcut this, and this is how, you know, we can start to think about some of these problems as we spend more time with them, is that the result of expanding these binomials, of these quadratics, is the term with the x in it is the sum of the two non-x values, and then the term at the end that has no x's in it. Right. So cubics, they're expanded in a very similar way to how we were doing our quadratics, with one extra step added on the end. Now, guys, this is some extension work. This is a little bit harder. So if you are having trouble with, this example we're going to have a look at, don't be too concerned. It might take you a couple of goes to get it right. So don't be dismayed. Stick with it, because it is a really good thing to get your head around. So the process is that we expand the first pair of brackets, just like normal. Okay, so we are literally just going to FOIL out these first two sets of brackets. We're not even going to worry about this one at this stage. Okay, let's do baby steps. So as soon as we've dealt with this first two pairs of terms, we'll come back and then we'll start thinking about this one. But for now, we'll ignore it. So I'll show you what that looks like. In our working, it looks like, as we said, FOILing out like normal. Okay, first, outer, inner, last. and we're going to write the result of that over here on the right hand side. Okay, so what I'm going to do here is I'm just going to use the that pattern that we saw earlier, where I'm going to add the 5 and the 2 to determine what number will be out front of my x term, and I will multiply the 5 and the 2 to figure out what value is going to be all by itself. So hopefully you agree with me that 5 plus 2 is 7 and 5 times 2 is 10. Okay, so there's a reason why I put these x's, these brackets over here around these two terms. It's not only to identify what I was going to do first, but also it's good to think about them as still being brackets after we expand them all out. Because now what we need to do, if we come back to our explanation, so we expanded the first pair of brackets, so we have done that, tick. Then we can expand the result with every term in the third set of brackets. So now we're not quite going to FOIL, but we are going to multiply by every single term in this first set of brackets with every single term in that second set of brackets. So let me show you what I mean. We're going to multiply the x squared by the x, okay? X squared plus times x, sorry, is going to give you the x cubed. And then the x squared times the 3x will give you the 3x squared. So it's, as I said, not quite FOIL a second time round because we don't have first, outer, inner, last, all that sort of stuff. With the extra term here throws that out a little bit, but the idea is very much the same. You're going to multiply every single term in here by every single term over there. So let's see how that goes for us. We've got the first one done, good, tick. Then we're going to move on to 7x. So 7x times x is going to give us the x squared. 7x times 3 will give you the 21x. Okay, so hopefully keeping track here. Last one, of course, will be our 10. So tick that one off. So 10 times these two terms here. There we go. So 10 times x is 10x. 10 times 3, of course, is 30. Now, like always, we do need to simplify. Now, this might be a little bit tricky, okay? We do need to be on the lookout for some more terms. So we are having a look and comparing our powers, okay? The powers are what determines what terms are like each other. So this x cubed, well, there's no other x cubed terms, so x cubed is not like any other term in here, so it's going to stay at the front by itself. The x squareds, however, we have 3x squareds here and 7x squareds here. So in total, 3 plus 7, we expect to have 10x squareds. 21x plus 10x, I should have 31 x's. Seems like a lot of x's. Let's see how we went. Happy days. Thanks, guys. There will be some opportunity for you to practice that with the worksheets. Have a go, submit some of those answers, and hopefully you're feeling pretty confident about this stuff. Remember, it is extension, so it is a little bit harder. So don't be, I guess, frustrated if you don't get it the first time. It probably will take you a bit of practice.